Operation management decisions. Operation management is essentially a function concerning decision making with operation respects to a production operation system so as to render the necessary customer satisfaction at lowest cost. The process of management. Essentially, management can be considered as a process of planning, organizing, coordinating, and control. There are different ways in which production management functions can be grouped for a sake of discussion. For instance, all the decisions concerning the production system could be delivered as a periodic decisions which include selection, design and updating of resources, structures, system and procedures. B. Continual decisions which are required in day-to-day operations and control of production systems. Strategic long term decisions. A decision is said to be strategic if it has a long term impact, influence a larger part of the system, and is difficult to undo once implemented. These decisions in the context of production system are essentially those which deals with the design and planning long range of immediate range aspects. Some example of these decisions are: a. Product selection and design. What products or services are to be offered constitute a crucial decisions. A wrong choice of production or poor decision design of the product may render our system operations ineffective and non-competitive. A careful evaluation of the product service alternatives or the on the multiple objectives basis can help in choosing right product. Yes. Techniques of value engineering can be useful in creating a good design which does not incorporate unnecessarily feature and can attain the intended function at the lowest cost. B. Process selection and planning. Choose optimal based under the circumstances and the purpose. Process of conversion system in an important decision concerning choice of technology, equipment and machines. Process planning pertains to careful detailing of processes of resource conversion required and their consequence. Include in such decisions can such decisions are the aspects of mechanism and automation. C. Facilitating location. It concerns decision regarding location of production system or its facility. A poor location may spell operating disadvantages for all times to come. Therefore, it is important to choose a right location which all minimize total delivered to customers cost, production and distribution cost or by virtue of location. Evidently such decisions call for evaluation of location alternatives against multiplicity of relevant factors considering their relative importance for the system under consideration. D. Facilities layout and material handling. Facilities layout planning problems are concerned with the relative location of one department activity center and with another in order to facilitate material flow, reduce handling cost, delays and congestion, provide good housekeeping facilities, facilitate coordination, etc. A detailed layout plan gives X blueprint of how actual factors of production are to be integrated. The types of layout will depend upon tile nature of production system. Most of the concept used in layout planning models are based on the importance of locating departments close to each other in order to minimize the cost of materials handling. Proper choice of the material handling equipment such as forklift, truck, con- conveyors, etc. is the related decision in layout planning. There are large number of computers packages developed such as craft, computerized relative allocation of facilities techniques, core lab, computerized relationship layout planning, etc., to help the layout planning for process based layouts. Balancing the production or assembly line and line design, including provision of interstate storage capacity, are some relevant issues in the product based layouts. Newer technologies, particularly computer based, are significantly altering the traditional concept of the layout planning. More recently, the concept in group technology GT, cellular manufacturing system CMS, and flexible manufacturing system FMS have influenced the layout planning and material handling policies significantly. Capacity planning. It concerns the acquisition of productive resources. Capacity may be considered as the maximum available amount of output of the conversion process over some specified time span. Capacity planning may be over short term as well as a long term basis. In service system, the concept of capacity and hence capacity planning is a bit more difficult problem. Long term capacity planning includes expansion and contraction of major facilities required in conversion process, determination of economics and of multiple shift operations, etc. Break-even analysis is a valuable tool for capacity planning. Other techniques like learning curves, linear programming, and decision tree are also useful tools in capacity planning. The above mentioned five decisions areas will be described in details in the unit immediately following this one. Operational or short term decisions. Operational level decisions deal with the short term planning and control problem. Such of these are Some of these are: A. Production planning, scheduling, and control. In operation scheduling, we wish to determine the optimal schedule and sequence of operations, economic batches, quantity, machines assignment, and dispatching priorities, and for sequencing production control is a complementary activities to production planning and involves follow up of the production plans. B. Inventory planning and control. These problems deal with the determination of the optimal inventory levels at raw materials in process and finished good stages of a production. Much to order. When order are two typical decisions involving inventories. Materials require planning MRP. Materials requirement planning MRP is an important upcoming concept in such a situation. C. Quality assurance. Quality is an important aspect of production system, and we must ensure that whatever production or services is produced in satisfied the quality requirement of the customers at lowest cost. This may be termed as quality assurance, setting standards of quality control and quality of products. Processes are some of the aspects of quality assurance. Value engineering consideration are related issued in quality assurance. D. Work and job design. These are problems concerning design of work methods, system and procedures, method involvement, elimination of avoidable delays, work measurement, workplace layout, ergonomic consideration in job design, work and job restructuring, job enlargement, etc. Design and operation of wage incentives is an associated problem area. E. Maintenance and replacement. This includes decision regarding optimal policies for preventive, schedule, and breakdown maintenance of the machines. Machine repair policies and replacement decisions. Maintenance of manpower, scheduling and sequencing the of repair jobs, preventing replacement and condition monitoring of the equipment and machines are Other important decisions involving equipment maintenance. Maintenance is extremely crucial problem area, particularly for a developing economy such as ours, because it is only through a very effective maintenance management we can improve capacity utilization and keep our plant and machinery productive and available for use. F. Cost reduction and control. For an ongoing production system, the role of cost reduction is prominent because through effective control of total cost of production, we can offer more competitive products and services. Cost avoidance and cost reduction can be achieved through various productivity techniques. Value engineering is a prominent technique available for the cost reduction. Concepts like standard costing and budgetary control help in monitoring and controlling the cost of labor, material, etc., and suggest appropriate follow up actions to keep this cost within limit. Monitoring and feedback control. In every system, the actual accomplishment of objectives may not be planned for various reasons. It is therefore very important to monitor the actual performance by measuring the actual output or some performance indicators. Basic elements of monitoring and feedback control, be it quality control of quality, time, inventory, or cost, are: 1. Established standard of performance or outputs. Second, measure actual performance. Third, compare the difference between the actual and planned. Fourth, take appropriate remedial actions by changing inputs, revising plans, changing priorities, expediting the progress, etc. Design of an appropriate feedback control system is therefore vital for all production operations management problems. Control is complementary to planning. Without monitoring and control, planning may not be effective. Without planning, control may not be effective. Thus, planning and control are two sides of the same coin. In the design of control system, we should consider cost benefit aspects of control in mind. If cost of control exceeds this its benefits, it becomes counterproductive. Those selective controls can be exercised employing the accepting principles or Pareto's laws. More effective controls could be self control or cybernetic or steering control, but it may be difficult to design such controls in large and complex organizations. Need for updating and review of decisions. When we plan or design our production system, the process of planning assumes certain external and internal environment on work. In a dynamic system, there may be changes in the environmental parameters which make our previous decisions out of date and irrelevant. In such situations, we need to review, revise, or update our decisions. For example, we may switch over a group technology layout from existing process types. We may add or delete our product lines. We may revise the product design in the light of new types of materials that are developed or on the basis of feedbacks from customers, etc. It is good practice to incorporate periodic review and updating as the part of our system so that our decisions are irrelevant to the prevailing circumstances and are compatible with the external environment. Thus, we should be able to revive all the previously stated decisions should be contingency of the situation so demand.